Okay, ladies and gentlemen, welcome back. Now we're on EE8. I'd like to congratulate you because this will be the last new thing that you learn in your 8th grade or pre-algebra year. Okay, and this one has to do with finding the probability of independent or dependent events. So the last one we looked at, you figured out whether it was an independent or dependent event. Now we're looking at what's the probability. Well, the first one we're going to look at is independent. And in an independent event, the thing that happened the first time really doesn't affect the thing that happened the second time. And calculating an independent event is actually pretty simple. You just take the probability of the first event times the probability of the second event. It's just that simple. So, for example, what's the probability of getting a heads on your first event and then probability of a tails on the second event? Well, the probability of getting a heads, as you know, is 1 out of 2. The probability of getting a tails is 1 out of 2. 1/2 times 1/2, as you remember, when you multiply fractions, you multiply straight across the top, straight across the bottom. 1 times 1 is 1, and 2 times 2 is 4. So the probability of flipping a coin twice, first getting heads and then getting a tails, is 1 out of 4. Another example would be, what's the probability of, when you roll a die, a six-faced die, what's the probability of rolling a 3 and then rolling an even number? Well, these are totally independent of each other. So we know that the probability of rolling a 3 is 1 out of 6. There are only 6 faces on a die, and only one of those is a 3. 6 faces, one of those is a 3. Now, the probability of getting an even out of those, there are 6 faces. Only 3 of those are even. 2, 4, and 6, so 3. Probability of rolling a 3 is 1 out of 6. Probability of getting even is 3 out of 6. And as I said, you multiply the two probabilities together if they're independent. Okay? 1 times 3 is 3. 6 times 6 is 36. And 3 goes into the top and the bottom. Goes into the bottom 1 time, goes into the bottom 12 times. So 1 out of 12 is the probability of rolling a 3 and then rolling an even number. That's independent events. Okay. Now the probability on dependent events is a little bit different because on the second event, the bottom number might change since something's been taken off of the table. So it's still found by multiplying the probability of the first event times the probability of the second event. But the difference is what happened in the first event might change the probability of the second event. Okay, so like if you took cards and didn't put them back. So let's looking at dependent events. Let's look at a card problem. So we got 1, 2, 3, and 4. And what we want to know is, what's the probability of picking a 4 and then the probability of picking a number less than 4? And you need to ask yourself, do we put the card back or don't? If we put the card back, then it's independent. So this would be without replacement. That's what makes it dependent. Because what happens on the first time is going, or might affect what happens on the second time. Okay, so the probability of picking a 4, well, there are 4 possible choices. Okay, so there's one of those is a 4. So the probability of picking would be 1 out of 4. Now that one's taken off of the table. Now what's the probability of picking a number less than 4 now? Well, there's a total number of 3 cards. And guess what? All 3 of them are less than 4. So now we multiply those two together. 1 times 3 is 3. 4 times 3 is 12. That reduces down to 1/4. There's a 1 in 4 chance of picking a 4, tossing it away, and then picking a number less than 4. That's one example. Okay, I think we're going to go ahead and do a couple more examples on another video to try to keep these below 5 minutes.